So good afternoon, everyone. So good afternoon, everyone. Welcome to the second problem solving session for this course. So I think many of you for many of you, maybe this is the first problem solving session. So let's just start with a brief introduction of all the participants. So I'll request you all to just unmute yourself and give a brief introduction about yourself, from which state you are, or whether for which company or institute you are associated with. So can we start with Aditya Tapkir? Can you please just unmute yourself and give a introduction about yourself?
Hello, am I audible?
Yes, yes, you are.
Yeah, this is Aditya Rakir uh, from Pune. Currently, I'm working in a company, Thermax Limited.
Okay. Okay then. Thank you, Aditya.
Hello.
Can we ask Akshay Mahajan to please unmute yourself and
Good afternoon, ma'am. My name is Akshay Mahajan, and I am an undergraduate student in Central University of Jammu.
okay. Thank you, Akshay. So Manoj Kumar, can you please unmute yourself and just give a brief introduction about yourself?
Good afternoon, all. Myself Manoj Kumar from Mangalore, Karnataka. I have completed diploma in petrochemical. Currently, I'm working in ONGC MRPL as a technical assistant. Thank you.
Thank you. Next is Mugesh Jay. Can you please unmute yourself?
Good evening, ma'am. J. Mukesh. I am PG student, Coimbatore, Tamil Nadu.
Thank you.
Thank you.
So let me first share my screen. Okay. So Manoj Kumar, you have raised your hand. So is there any doubt or it is by mistake?
Yes, madam. Actually, I have a doubt. First, while applying, I did notice that this course is the course basic eligibility for the course is a bachelor degree, but I didn't complete my bachelor degree. Am I eligible to attend the exam?
So you.
I completed.
Mm-hmm.
Pardon me. I completed diploma in petrochemical. So I just joined this course because I want to do research, some things I'm doing on. So regarding that, I want to gain my knowledge. So I up this course. So am I eligible to attend the exam?
So you just write a mail to the NPTEL
Okay.
team. They will clarify this doubt about whether you are eligible to appear in the exam or not.
Okay. Thank you. Thank you.
So good afternoon, everyone. Welcome to the second problem solving session for the course Waste to Energy Conversion. The course instructor is Professor P. Mundal from Department of Chemical Engineering, IIT Roorkee. I am one of the TA for this course. The session for me is scheduled from 3 to 5 p.m. on Saturday, and I am a PhD scholar in Civil Engineering Department at IIT Kanpur. So we will start with a very brief introduction about of what was taught in module 2, that was the B week 2 lecture, and then we will directly go to the previous year assignment questions. So in week 2, there were 5 lectures. The first lecture was about I think it was for some questions related to the week 1 module. There was, I think, 3 to 4 questions, practice question based on what was taught in week 1. And the second and third lecture was about incineration, followed by fourth lecture for numericals on incineration, and the last one was for gasification. So in week 1 we have studied about what is waste, its classification and characterization of different waste. That was the solid waste, wastewater, and In the second week, introduction about incineration was given. So, incineration is complete combustion of anything in presence of excess of air to produce CO2, water vapor, along with the heat. And the heat which is generated, it is used to produce electricity, or it is used in some other ways. So for if the incineration is not complete, then lot of pollutants will be generated. So some of the condition for complete combustion is fuel to air ratio. It is very important that fuel to air ratio should be optimal, and also in fact air in higher quantity as excess air is provided for the complete combustion of the waste. Next is time. Optimum time should be provided for the incineration to takes place. There should be a proper mixing conditions in the reactor so that all the waste is combusted. And finally the temperature. Next is the temperature. So the temperature should be the optimum for the combustion to take place. Next is air requirement. So this is the general equation, which is CHNSO ash. This is the general elemental composition of the waste. So A, B, C, D, E, F are the moles of these elements in the waste. So we get the formula of the waste. Then we can find out how much oxygen is required to convert this into carbon dioxide, nitric oxide, SO2, H2O, and ash. And generally excess air in the range of 5 to 50% of what is required stoichiometrically is provided for the incineration to take place. For stage combustion are more efficient as compared to the conventional combustion. In stage combustion, either air is provided in two stages or fuel is provided in two stages. Next, this slide shows some of the advantages and disadvantages of combustion. So advantage is it is very low cost, it is very reliable, and the volume of the waste is reduced very much in incineration. Around 80 to 90% of the volume is reduced in combustion. But there are some disadvantages. First is the fuel quality. Next is if the waste is hazardous or it contains some of the pollutants, then the flue gas after incineration will have those elements or compounds, and it may cause air pollution. So there is a requirement of cleaning of the flue gas before discharging in the air atmosphere. Also the requirement for space is large, but incineration, if we compare it with the other method, conventional method, that is landfill, which is one of the most conventional method used in our country to dump the solid waste. So compared to that, incineration is better. Its space requirement is less, but if we compare with other methods, then there is a requirement for space for storage of the waste materials to be incinerated. Next is some of the pre-treatment is required before incineration. First, we have to sort the waste, whether it is combustible or not. Then we have to homogenize, decrease its size, and then we can incinerate in the incinerator. So, based on the reactor type, there are two types of incineration. First is the fixed bed combustion, and next is the fluidized bed combustion. The difference here is in fixed bed, the waste is put on the bed and air and fuel is provided. Whereas on fluidized bed combustion, there is a fluidized material like sand are used in the reactor, which flows along with the waste and it is combusted into the reactor. Again, if you see the fluidized bed reactor, it is of two types. First is the bubbling fluidized bed reactor. Next is a circulating fluidized bed reactor. So if we see the circulating fluidized bed reactor, it has higher air velocity, and here the recirculation of sand and unburned waste takes place. So its efficiency is higher as compared to the bubbling fluidized bed reactor. So the next shows the advantages of fluidized bed combustion over fixed bed combustion. Obviously, fluidized bed is better in terms of efficiency. It also requires lesser fuel, and operating temperature is also lower, and it has higher combustion efficiency. And it is also suitable for large scale operation as compared to the conventional fixed bed combustion reactors. So if we see the environmental aspects of combustion or incineration, then since combustion is taking place, since then some NOx will be generated, SOx will be there, and if the compound contains elements like mercury or some other organic pollutants, then mercury and dioxins will have to be removed. Basically the flue gas will have to be cleaned before discharging in the atmosphere. There should be acid gas removal, the particular matter has to be removed, and then only we can discharge the gas. Next is some of the operating problems. These are the slagging, that is deposition of the ash on the walls, or corrosion of the boiler tubing, and erosion due to the pollutants in the gas. Next, this slide shows oxygen to coal ratio that is required for the three processes, that is combustion, gasification, and pyrolysis. So combustion takes place in presence of excess of air or oxygen. In gasification, we give limited amount of oxygen, and in pyrolysis, there is no oxygen or air present. So if we see the ratio R, that is greater than 2.5 for combustion. For gasification, it is within 0.68 to 2.5, and pyrolysis, this oxygen to coal ratio is less than 0.68. So all these values are taken based on oxygen to coal ratio, because these methods were initially generally used for coal, and from there it is being applied to the solid waste for combustion, gasification, and pyrolysis. So here it is a general gasification reaction scheme. All these screenshots have been taken from the module itself. So first feedstock is given, it is heated, so volatile escape from the waste, and then we get the char, and finally the char is gasified, and also the volatile has volatile is also gasified, and we finally get the syngas, and this syngas has some calorific value which can be further used in various processes. So this is there is also a small formula is given for gasification of volatile. So volatile generally consists of carbon and hydrogen. So this is a formula, how much oxygen will it require to produce carbon monoxide and hydrogen. And if there is also a formula given for char gasification, this may be required while we will solve the numericals based on gasification. So the factors which influence the gasification is, again, it will depend upon the uh, gasification agent used, whether air is used or oxygen is used, what is the type of heating, temperature range, pressure, and type of feed injection. Different methods are used for feeding the waste in the reactor. So some of the advantages of gasification is that CO2 emission is less. CO2 is a greenhouse gas. So in gasification, we are converting the waste into syngas, which can be used to generate some sort of electricity or can be used in industries. So we are reducing the emission of CO2. Also, the area requirement will be lesser because compact equipments are used in gasification. There is a lot of control over combustion, and the efficiency is very high as compared to incineration. So based on the reactor, we have three types of gasifier: fixed bed, entrained bed, and fluidized bed. And I think next we have the numericals. So this was the brief introduction about what was taught in the module 2. So it was basically about incineration and gasification, and two lectures was about solving the numericals based on incineration and characterization of waste. So here we are going to solve the previous year assignment questions. So it will consist of questions based on both incineration and also on characterization of waste, which was there in the week 1. So I hope every one of you have gone through the lecture material. If you have not, I would request you all to please go through that. If there will be some numerical, then definitely I will give you the um, uh, background about that how we are going to calculate this, and then I will request you all to please try to solve that questions. Also, I will provide you all around 2 to 3 minutes or 5 to 6 minutes based on the whether it is a numerical or single word question, and then you all have to just write the option or the correct value in the chat box, and then we will see how to solve that question. Also, there may be a one or two question which I have added from my side. So we will also try to solve those questions. So let's move to the first question. If you have any doubt then you can just unmute yourself and you can ask while I am explaining the questions. So we have to identify the given figure. So the figure is, so this is the figure. This figure is from the lecture slide only. So we have to identify whether it is a rotary kiln, ball mill or a dryer, or D, none of these. So I'll give you all 2 minutes. Just take your time and write your answer in the chat box. I'll request every one of you to please participate, and whatever you think is the correct answer, just write that in the chat box. So the correct answer is A. This figure shows a rotary kiln. So let's move to the next question. So the question is, what is the range of excess air requirement for effective combustion of waste and biomass? So these are the options: 70 to 90%, 5 to 50%, 5 to 5%, 90 to 100%. So I'll give you 2 minutes. Just write your answer in the chat box. So let's see which is the correct option. So we have seen this in the slides also, which I have presented just now. So the correct answer is B, that excess air requirement for effective combustion is generally between 5 to 50% for waste and biomass. So let's see the next question. So it is a numerical. So it is here we have to find out the moisture, volatile matter, ash and fixed carbon percentage. So the question is, 1 gram of an municipal solid waste sample is heated at 105 degrees centigrade for 24 hours, and the weight of the dried material is found as 0.8 gram, which is further heated in a furnace at 950 degrees centigrade for 7 minutes in absence of air by putting the lid of the crucible. The weight loss is found as 0.4 gram. The remaining material is cooled with a lid cover. When the temperature reaches to ambient temperature, its lid is opened and it is further heated in an oven at 5 degrees centigrade for half an hour in presence of oxygen. After cooling the material, the residual mass of the material is found as 0.12 grams. Determine the moisture content, volatile matter, ash and fixed carbon of the waste. So here a municipal solid waste is given. It is heated at different temperature for different time interval based on whether we have to find out the moisture, volatile matter, ash content, and we have to find out what is the percentages of these. So I'll give you all 5 minutes. So please try to solve this question and write the correct option in the chat box. So let's see how to solve this question, and the correct answer is option C. Okay, let's see how to solve this question. So it is the proximate analysis of the waste. In proximate analysis, we find out moisture content, volatile matter content, ash content, and by subtracting moisture, volatile matter, and ash content from 100%, we get the fixed carbon content. So let's see what is given here. Given is weight of municipal solid waste taken is 1 gram. First, we have to find out the moisture content. So I'm writing MC as moisture content. So for any waste or any material, to find out the moisture content, what is done, that waste or material is dried at 105 degrees centigrade for 24 hours. So from the first line, we can see that the waste is dried at 105 degrees centigrade for 24 hours. So moisture content is given as, what was the initial weight minus the final weight after 24 hours divided by initial weight, and since we have to find out in percentage, so into percentage. So the initial weight of the material is so the initial weight of the material is 1 grams minus the weight after drying at 105 for 24 hours is 0.8. So 0.8 upon the initial weight, which is 1 into 100. So it will be 20%. Next is we have to find out the volatile matter content. It is given as the weight loss divided by initial weight into 100. So weight loss divided by initial weight into 100. So in the question, the weight loss is given as 0.4 grams. And if the weight loss is not given, but the initial weight and the final weight, the initial weight before keeping the crucible in the furnace and the final weight is given, then by subtracting these two weights, we can find out the weight loss, and it is given, and we can find out the weight loss, and we can find out the volatile matter. The weight loss is 0.4 grams. Initial weight is 1 into 100. So it is 40%. Next, we have to find out the ash content. So ash content. So after drying at 105 for 24 hours and after putting in the muffle furnace at 950 for 7 minutes, whatever is left, then it is kept in the muffle furnace at 750 degrees centigrades for half an hour, and whatever is left in that crucible, then that is the ash content. So in the question, so in the second last line, we can see the residual mass of the material is found to be 0.12 grams. So ash content is given as weight remaining upon the initial weight into 100. So from the question, I think 0.12 grams is remaining. So it is 0.12 upon initial weight, that is 1 grams into 100. So we are getting 12%. So we got the moisture content, volatile matter content, ash content. We need to also find the fixed carbon content, and it is subtracted from 100% minus moisture content minus volatile matter minus ash. So we have 100 minus moisture content was I think 20%. Volatile matter was 40%, and ash content is 12%. 60, 70, 72. So after subtracting this, we will get fixed carbon content as 28%. So based on this, moisture is 20, volatile is 40, ash was 12 and 28. C is the correct option. So I hope this question is clear to everyone. So if any one of you have any doubt, you can just unmute yourself or you can write your doubt in the chat box about this question. So if you all do not have any doubts, so let's move to the next question. Okay, clear, ma'am. So Manoj Kumar has raised his hand. So Manoj, what is your doubt? Manoj, can you hear me? So I think there is some connection issues from Manoj's side. So Manoj, if you're not able to unmute yourself, you can just write your doubt. So there I can you just write your doubt in the chat box. I will read it from there and
Madam,
then yeah.
madam, sorry for interrupting. Am I audible now?
Yeah, yes you are.
Madam, that first for the drying period after that, sorry, around 105 degrees Celsius, around 24 hours,
Mm-hmm.
we allow them to cool it down and again for 7 minutes for 950 degrees Celsius.
Yes.
And that after that, it's allowing in crucible, it's allowed to cool it by the close the lid.
Yes, the crucible is kept in the muffle by closing only, and then it is cooled in the desiccator in the closed condition only.
But how the heat transfer will takes place, madam? Because it's a closed container. Then
No, no,
and also
not.
if the furnace.
Yes, yes.
Sorry. You continue, madam, please.
What
Go
I'm
ahead. Go
telling
ahead.
is, suppose we have to find out the moisture content. So we take some amount of
Correct.
waste in the crucible, we keep it in the oven for 24 hours. Then after we take the crucible out of the oven and we keep in a desiccator.
Oh, okay,
So
madam.
desiccator
Okay.
has some silica materials which absorb the moisture. So after
Oh, okay,
cooling,
madam. Okay.
after cooling in the desiccator, we further put the crucible along with the lid in the muffle furnace for 7 minutes. And then again we take
Okay.
it out from the muffle and then we cool it down in the desiccator and then we find out the weight.
Okay, madam. Okay. Madam, okay. Thank you, ma'am.
Okay. So let's go to the next question. So let's move to the next question. So the question is, gasification of the biomass and waste converts its organic part into combustible by interaction with oxygen and steam so as to obtain a secondary gaseous fuel of high calorific values having no ash. Gasification reaction in fluidized bed gasifiers are normally carried out at about. So we have to find out what is the temperature at which the gasification in fluidized bed gasifiers takes place. So I'll give you all 2 minutes. Just write the option in the chat box and we will see which is the correct option.
Hello, ma'am.
Yes.
Excuse me, ma'am. Ma'am, option B is the right option, ma'am.
Okay, let's others also write their answers in the chat box. Then we will move to the answers.
Yes, ma'am. Okay.
So this question is directly from the slide. The temperature for fluidized bed gasifiers is between 900 to 1200 degrees centigrade. So let's move to the next question. The question is, which grade resembles stairs with alternating fixed or moving grade sections? The options are the roller grade, the rotary kiln, the reciprocating grade, or none of the above. So again, I will give you all 2 minutes. Just write your answer in the chat box. So I've got only one answer as A. So let's see. So C is the correct answer, that the reciprocating grade resembles stairs with alternating fixed or moving grade sections. So I have a doubt from Akshay Mahajan whether this the PDF version of these assignment questions is available. So the slides which I am using, also the video of this session will be uploaded, and the link for you can find out in the NPTEL portal. I think there is a section called problem solving sessions. So if you will click that, then you can go to drive link where you can see the PDF for these sessions, and also you will get link to the YouTube videos, because we are supposed to upload these videos in the YouTube, so you can also watch from the YouTube, or also you can refer to the PDF from the Google Drive link. So you can download the PDF, or anything you would like to see. So you can get the PDF from there. So let's move to the next question. So the question is, what is the value of R oxygen to coal water with in weight to weight ratio for gasification processes? So this is a direct question from the lecture slide. Also, I have given that slide in the summary of the previous weeks. So the options are R between 0.68 to 2.5, R less than 0.1, R less than 0.868, or R greater than 3.5. So we have to find out what is the value of R for gasification processes. So I'll give you all 2 minutes. Just write your answer in the chat box.
Excuse me, ma'am.
Yes.
Ma'am, option D, I think.
Uh, Please write your answer in the chat box. From there I can read. Okay. Let's see. So I got one doubt that how to solve this question. So this is a straightforward question from the slides itself. Let me share that slide. So the question is from this slide. We have to find out the R value for the gasification process. So we have to remember the R value for gasification, that it is between 0.68 to 2.5. So it is 0.68 to 2.5. So for a combustion it is greater than 2.5, and for pyrolysis it is less than 0.68. So here we do not have to do anything. We just have to remember the value from the slide. So let me go to that slide. So the next question is, if air is used in place of oxygen in gasification process, the product gas is known as syngas, coke oven gas, producer gas, or gobar gas. So this question is also directly from the slides. So I'll give you all 2 minutes. So please write your answer in the chat box. So the correct option is C. If air is used in place of oxygen, then the gas produced is known as a producer gas and it has lesser calorific value as compared to the syngas because we are using air and it has nitrogen, so it will dilute the gas produced. So let's move to the next question. So it is a numerical based on characterization of wastewater. So the question is, COD analysis of a wastewater sample is carried out through chemical method using N by 10 K dichromate solution as reducing agent. Excess dichromate is titrated against FAS, that is ferrous ammonium sulfate. 200 ml of wastewater sample is used. The titer values of ferrous ammonium sulfate are 60 ml and 85 ml for original sample and blank sample respectively. Determine the COD of the sample. Assume there is no interfering element in the sample. So we have been given that we are taking around 200 ml of sample and we are titrating it with potassium dichromate. The value for blank as well as for the sample is given and we have to find out the COD. So this question is based on characterization of wastewater from week 1. So I'll give you 5 minutes. Please try to solve this question and then we will see how to solve this question. And whatever option or value you are getting, you just write that in the chat box.
Excuse me, ma'am.
Yeah,
Ma'am,
yeah.
can you hear me?
Yes, yes, I can hear you.
Ma'am, in this lecture only, in which this lecture one series, which from which this question is put, like on that series, the third question of like industrial wastewater, in which BOD was has to be calculated. I'm not able to solve that one question. Can you explain that one also, please?
So, is this question from the current assignment?
Not from assignment, ma'am. From the lecture.
Okay, from the tutorial?
Yes, ma'am. Tutorial lecture.
Okay, okay, okay. I will. So, after completing all
That
the
is that
questions
is
from, yeah.
Yeah, ma'am. This one is of COD, and that was of BOD, like industrial wastewater is tested for measuring. You can check like that is third question of that lecture.
Okay, okay, okay. After completing all the 10 questions from this assignment, I will open that PDF and then I will
Okay,
explain.
and thank you.
Okay.
Mhm.
Okay, I haven't got any answer. Let's see how to solve this question. So we can calculate the COD. Okay, I got one answer as 200. So let's see which is the correct answer. So we can calculate COD using this formula, that COD equals to 5000. B is for the value of titrant for blank and S for the sample into N, where N is the normality of FAS divided by sample volume. So let's see what is given. So we have been given that we are using 1 by 10 normality. Let's just write the normality of potassium dichromate. It is N by 10, that is 0.1 normal. So volume of wastewater sample is, yes Tanya, you have raised your hand. Okay, okay, let me reshare my screen. Is the screen visible now? So no, but I can see my screen on the other device. Can anyone else confirm whether the screen is visible or not?
Yes, madam. Yes, madam. It's visible. Visible.
Okay, so Tanya, I think there is some connectivity issues from your side. So the volume of sample taken is 200 ml and okay, the volume of FAS consumed for blank is 85 ml. It is B. And for sample, which is S, is 60 ml. And this is V. And this is N. So COD of the sample is equals to 8000 into B minus S into normality of FAS divided by the volume of the sample. So we have 8000 into B is 85 minus 60 into normality, I guess 0.1 divided by 200 ml is the volume of the sample. So after solving this, we will get the COD of the sample in milligrams per liter, and it is coming out to be 100 milligrams per liter. So B is the correct option, not 200. Okay, let's move to the next question. So this is also a numerical. So it is, yes, Manoj?
Madam, sorry for interrupting you. Can you show me that COD formula once again? That slide. Yeah, yeah, the same slide. Correct, correct. Previous one. Yeah, madam. Once again. Thank you, thank you. Yes, madam. Thank you. You
Okay,
can
okay,
proceed.
yeah,
You
yeah,
can.
yeah. So this question is based on the experiment for finding the calorific value of any waste, solid waste. So we have also solved one question similar to this, but we have find out the calorific value in the previous problem solving session. And also I think there is one numerical based on this in the current assignment also. So we have to determine the water equivalent of a bomb calorimeter in which 1 gram of benzoic acid sample was used. The experiment produced a net corrected temperature rise of 5 degrees centigrade. The acid titration required was 12.5 ml of standard alkali and 8 centimeter of par 45C10 nickel chromium fused wire was consumed in the firing. We have to determine the water equivalent of the bomb calorimeter. So just let me provide the basics for this question. So we can know that we can find out the gross heating value as Hg is W into delta T minus even, okay, let me write. So gross calorific value is given as W into delta T minus E1 minus E2 minus E3 divided by mass of the sample taken. So if we rearrange this equation, we will get this, where W is the water equivalent of the calorimeter in calorie per degree centigrade. So we have been given all the values, we just have to find out W. So all the notations are given on the slide, where H is the gross heating value, M is the mass of sample in gram, T is the net corrected temperature, W is the water equivalent which we have to find out, E1 is correction for heat of formation of nitric acid, E2 is correction for heat of formation of sulfuric acid, and E3 is correction in calories for heat of combustion of fused wire. So we have to find out E1, E2, E3, and just we have to put in the formula and we will get the water equivalent of the bomb calorimeter. So I'll give you 5 minutes Just take your time and try to solve this question and write the correct option in the chat box. So till now, I haven't got any answer. So let's see how to solve this question. So in the question, I think the calorific value is given. So let me open a new slide. So the gross calorific value is given as 8500 calories per gram. The amount of sample we are taking is 1 grams, and amount of alkali is, let's see, it is I guess 12.5 ml. C2 is 0 and C3 is 8 cm of the wire is used, and the net corrected temperature is difference is 5 degrees centigrade. So now we have to find out E1, E2 and E3. So E1 is calculated as 12.5, that is amount of alkali used, into 1, that is 12.5 calorie. Okay. Next we have to calculate E2. E2 is given as 13.7 into C2. C2 is the amount of okay. So C2 is given as 0 because it is not mentioned in the question. So 545C10, it is the type of the wire which is being used in the bomb calorimeter. So this is the nickel chromium fused wire. Its specification is given as PAR 45C10 nickel chromium fused wire. So next we are going to calculate E3. E3 is given as 2.3 into C3, where C3 is the centimeters of fused wire consumed in firing. So E3 will be, E2 will be 0 because C2 is 0. It is not mentioned in the question. E3 is 2.3 into C3, that is centimeters of wire consumed, that is 2.3 into 8 centimeter. So after solving this, we are getting 18.4 calories. So I have given you the formula that we can find out W as Hg into M, that is mass of the sample taken, plus E1 plus E2 plus E3 upon delta T. So we have everything
Ma'am, can
given.
you explain
Yeah,
E3
yeah.
again, please?
Sorry.
Can you explain E3 again?
Okay. So we find out E3 is in correction for the fused wire which is used. So E3 is given as 2.3. This is the value based on empirical calculation into C3, where C3 is the amount of fused wire which is being used in firing in centimeters. So we can see from the question that 8 centimeter of PAR 45C10 nickel chromium fused wire is consumed. So here C3 will be 18. So we can find out E3 as 2.3 into 8. Sorry, C3 will be 8. So E3 will be 2.3 into 8. And we can find out the correction in calories for heat of combustion of fused wire. So now is it clear, or do you have, or still you have any doubt? So can you please confirm? Okay. So we have calculated E1, E2, E3, Hg is given, M is given, change in temperature difference is also given. So we just have to put this in the formula and we'll get what is the water equivalent. So Hg is 8500 into 1 gram of the sample is used, plus E1 is 12.5, E2 is 0, and E3 is 18.4 divided by 5. So after solving this, we will get water equivalent as 1706 calories per degree centigrade. So this is the final answer. So I have one doubt is where can I get lecture videos of these problems? So just now I told you that you can access these videos, and also the PDF of these presentation will be uploaded in the NPTEL portal. There is one section called problem solving sessions. If you'll go that, in that section you will get a link to open a, you will get a Google Drive link. From there you can you will be forwarded to a Excel sheet. In that Excel sheet there will be link for both the PDF and also the video for the session. So you can access the videos and PDF from there. Okay. Okay, let's move to the next question. So again, it is a numerical type question and it is based on the characterization of waste only on the module 1. So the question is 3 gram of a dried agricultural waste is leached with benzene and ethanol mixture 2:1 volume by volume at 60 degrees centigrade for 3 hours. After leaching, the residue is dried in a hot air oven at 105 degree to a constant weight of 1.6 gram. This dried material is put in a flask containing 150 ml of N by 2 NOH solution. The mixture is boiled for 3.5 hours with recycled distilled water. After this, the residue is washed with distilled water till all the sodium ions are removed and dried to a constant weight of 1.3 grams. Determine the extractives and hemicellulose content of this waste on a dry basis. So basically in the question, the overall procedure is given and all the values are given, and we have to find out the amount of extractives and hemicellulose contained in percentage. So I'll give you the background for this question. So we can analyze the cellulose, hemicellulose and lignin as follows. So to find out the extractive, dried sample is leached with benzene and ethanol mixture, which was given in the question. So the extractive is given as M0 minus M1 by M0, where M0 is the dried weight of the samples and M1 is the final weight after leaching. And by using this formula, we will get the extractives. And similarly, in hemicellulose, the residue which we get from after the extraction of extractive, that is M1, this residue is put in a flask with 150 ml of NOH solution, and then the mixture is boiled for 3.5 hours with recycled distilled water, and the residue is washed with the distilled water till no sodium ion is present. It is also given in the question, and it is then dried to a constant weight, and this weight is M2. So the amount of hemicellulose is calculated as M1, which was the amount which we get after extraction of extractive, and then M2 is the final weight which we get after extraction of the hemicellulose upon M0, that was the initial dried weight, into 100. So using this formula we can get the hemicellulose. So I think in the question extractive and hemicellulose was to be calculated. So everything is given in the question. The amount of dried waste is 3 grams. So M0 is 3 grams. So after leaching, the residue is 1.6 grams. So we have M1. Then again, after putting it to the hemicellulose extraction method, the final weight is given as 1.3 grams. So M2 is also given. So we just have to put in the formula and find out the extractives and hemicellulose content. So I'll give you all 3 minutes. Sorry, let's keep it to 5 minutes. Just take your time and try to solve this question. And if you have any doubt, like, let me, so if you have any doubt in between for that you want the formula or like that, you can just unmute yourself and say, then I will switch to that slide. Okay, just take your time, solve the question and write the answer in the chat box. 46.6 and 23.6. Okay. So A is the correct option. So let's see how to solve this. Okay. So we have been given that 3 gram of dried waste is taken. So M0 is given as 3 grams. Next, it is given that weight after extractives is given as, I think, 1.6, or yeah, it is given as 1.6 gram. So here. So we can find out the extractive content as initial dried weight minus weight after extractives upon initial dried weight into 100. So it will be 3 minus 1.6 upon 3 into 100. So after calculation, we will get 46.66%. And in the question, the weight after hemicellulose extraction is given as 1.3 grams. So hemicellulose content it is given as M1, that is weight after extractives, minus M2 upon M1, not M1, upon M0, that is the initial dried weight, into 100. So we have M1 as 1.6, M2 as 1.3, and initial dried weight as 3 into 100. So after solving this, we will get 0.3 by 3, that is 10%. So A is the correct option. So the extractive content is 46.6% and hemicellulose content is 10%. So these are the question. Okay. So yes, Manoj.
Madam, this formula which we obtained from the previous slide, there that extractive solution normality is given on a particular concentration. Whether this is constant or it is changeable.
No. For any experiment, this is constant. The normality of
Okay.
NOH which we will use, it is constant. It is n by 2 only.
What? So what about the times, madam?
What about?
The time schedule, the time for that experiment, for example, 3 hours and boiling hours, 3.5 hours.
So these are same now, that for extractive it is 3 hours and for hemicellulose it is 3.5 hours. So you are telling about that NOH is given as 20 milligrams per liter.
Correct, madam. Based on that that formula schedule you showed on previous slide.
Just wait a minute. So can you see my slide? Yeah. So if you will calculate the normality of NOH from here, that is 20 grams per liter.
Correct,
here,
madam.
so it will be 0.5 only. So let me. So the molecular mass for NOH is 40. So 20 upon 40 is 0.5 only. So n by 2 only. So the strength
Okay,
of
madam. Okay.
chemicals used will be same, and also the time for which it is boiled will also be same. So the way
Thank you.
in
Thank
which
you.
it is written in the question is different, but the values are exactly the same.
Okay. Thank you. Thank you so much.
Okay. So we will move to the BOD question. So just give me a minute. Let me. So this is the question which Tanya has mentioned. So we have to find out an industrial wastewater is treated for BOD 5 value. The wastewater is diluted 100 times with dilution water before it is used in the test. The OD of 1 real, it is DO, not OD. The DO of 1 real and blank sample are determined, which is 10 ppm. Other two BOD bottles filled with real and blank sample is incubated for 5 days at 20 degrees centigrade. After 5 days, the DO value of real and blank samples are found as 3 and 9.7 ppm. Calculate the BOD of the original water sample. So there are two questions. In the first part, there is no seeding is done, but in the second part, seeding is done. So for the seeding, so the first part in which seeding is not done, BOD is calculated using this formula. That BOD5 is given as D is the dilution factor into DO initial minus DO after 5 days for sample minus DO initial minus DO after 5 days for blank. So if we see here, so the dilution factor is 100. Why it is 100? Because it is mentioned in the question that the wastewater is diluted 100 times with dilution. So dilution factor is 100 here. And for both sample and blank, the initial DO is given as 10 ppm. So DO initial will be 10 for both sample and blank. Again in the question, it is given that after 5 days, the DO for sample and blank is, for sample it is 3 ppm and for blank it is 9.7. So if you will subtract, so if you put it in the formula, so it will be dilution factor, that is 100 into 100 minus 3, that is the initial DO and final DO for the sample, minus initial DO and final DO for the blank. So after solving this, we will get 670 ppm. So the next part is that some microbial seeding is done. It is done and for, sorry, in 5 ml of the, if 5 ml of microbial. So yes, Tanya. So do you have any doubt? Yes. So actually can't see you. Oh, oh, okay. Is the screen visible now? I think Tanya, there is some issues from your end because I can see my screen on the other devices. Okay. Okay, so without seeding, the BOD will be 670 ppm. And next part is if 5 ml of microbial seeds are used in the preparation of 300 ml dilution water, how the BOD value will differ. So let's move to the next part. So if seeding is done, then this formula is used. Like there is one factor small f, which is the ratio of seed volume in dilution solution to the seed volume on in BOD test on seed. And nearly this value is 1. So in this part, we just have to find out f. And f will be, I think 300 ml is the final volume of the BOD bottle. And in that, we are adding 5 ml of the seed. So it will be 5 into 300 upon 5 is the value of the, let me go to the question. So I think there was some dilution also. It was 100 times. So F is calculated as 5 is the amount of the seeds which is taken and the final volume of the BOD bottle upon 5 is the amount of the seed into 297. It is multiplied with 297 because for 100 time dilutions 3 ml of the real wastewater is added with 297 ml of the blank or dilution water. So it will be 297 and this factor is given as 1.01. So after getting this factor, we can simply put it in the BOD 5 formula and we will get the BOD of the seeded dilution sample. So is the solution clear now? Tanya, can you confirm?
Ma'am, I'm not able to get the 297 where it comes.
So see, the sample here is diluted 100 times and the final volume is 300 ml. So if you want to dilute something to 100 times and you have the final volume as 300 ml, then definitely you will take 3 ml of the sample and you will mix it with 297 and the final value will be 300. So 300 upon 3, that is 100. So for getting the dilution factor as 100, you have to take 3 ml of the sample and dilute it till 300 ml.
Okay, ma'am. Thank you.
So this part is just for the dilution factor. Yes, Manoj? Manoj has raised his hand.
Yes, madam. Sorry. Actually, there it's mentioned as 100 times dilution. But you told that if you want to 100 times dilution means if I mean for 300 ml 1% of the real that wastewater, the remaining 99% diluted water. But then how it's became
No, it's not
100%
in
there?
percentage. It is in times.
Sorry, yeah. Then it is not 100 times, man. It's 99. We can say we can't.
No. If you are taking anything 1 ml and you are diluting till 100, then it is 100 upon 1. That is 100 times only. Since the
Yeah, but we are. Sorry. You continue. Sorry.
No,
Proceed.
you say what is the doubt?
Yeah, madam. But what I understood from this the last slide, she asked about the 297 ml, how it came. So you mentioned as for 100 times dilution factor, 3 times of real water.
No,
It's
3
ordered
ml of
with.
real.
Sorry, yeah, correct. 3 ml of real the wastewater is ordered with 297 ml of the dilution water. So which means for 100, so we will get 300 ml.
Yeah.
So but here we not actually added the 100. So I think it's 99. So sorry if my question is wrong. I don't know whether I'm asking. Madam, actually, what I'm asking for 300 ml, I divided into 300 portion. In that, I consider if it is 100 times means 100 ml of that 300 ml water I have to add. Like that, I understood.
No. For dilution, the final, suppose we have to make 100 ml. So the final volume will be 100 ml. In that 100 ml, we will add 1 ml of the wastewater and 99 ml of the blank. So that will be mixed. That will be the overall 100 ml. So that will be 100 upon 1. Like this, we calculate the dilution factor. That is total volume divided by the amount or volume of the wastewater or any sample we add.
Okay, thank you.
Okay, so since the BOD bottles are generally of 300 ml capacity, so that's why we are taking 297 ml of the dilution water and 3 ml of the wastewater. So 297 plus 3 will be 300 ml. So final volume, that is 300 divided by the volume of sample taking, that is 3. So 300 upon 3 will be 100.
Okay, thank you.
Okay. So these were the questions based on assignment 2. So the next week we will have the session from on Saturday only from 3 to 5 p.m. So I'll request you all to please join the sessions. Also, please go through the lecture material and the tutorials. The questions which are solved in the lectures only, please try to see that, and then we will try to solve the questions based on the module 3. So thank you so much for joining. If you have any doubt, then you can ask, or otherwise we can end the session here. Okay. Okay, so I'm ending the meeting here. So thank you so much for joining. Have a nice day.
Thank you,
Thank you,
ma'am.
madam. Thank you. Thank you.